Here's an example with basic electronics. Let's calculate the equivalent resistance of this circuit. First, we recognize that these two resistors are in series, so the equivalent resistance of those two is 300 ohms. And now we have this equivalent circuit, 300 ohms, and then our 400 and 600 ohm resistors, and these are in parallel, so we use the equation for parallel resistors. Our equivalent is 1 over each of the resistors added up in the denominator, so this would be 1 over 300, 1 over 400, and 1 over 600, and when you plug that in you get 133.33 ohms, which is the equivalent resistance of this circuit. Now part B is to calculate the total current through this circuit. Well, we know that delta V, some people use E for, I'll use V for voltage, delta V equal IR, that's Ohm's law. So we calculate the current, I equal delta V over R. We'll use the equivalent resistance, so the voltage across this circuit was 10 volts, 10.00 minus 0.00 volts, over the equivalent resistance, 133.333 ohms. The unity conversion factor, which is equal to 1, so we can multiply amp times ohm is a volt, and so we get 0.0750 amps, and that is our current, or 75.0 milliamps, giving our answer to 3 significant digits. Part C is to calculate the power used by this circuit. So we write power, W dot, is change in voltage times current, and from Ohm's law, change in voltage is IR times another I, so this is equal to I squared R, or W dot equal delta V times I equal delta V over R, where again we use Ohm's law to get this in place of I, and therefore this is equal to delta V squared over R. You can use either of these equations, you should get the same answer. Let's pick the second one, 10.0 volts squared over 133.333 ohms. Unity conversion factor, a watt is a volt times an amp, and an amp times an ohm is a volt. So the units, we want our answer in watts, and of course we get volts squared cancel, we get amps cancel, we get omega, which is the symbol for ohms, canceling, and so we end up with simply watts, which is what we want. And when we plug in, we get W dot, the power, is equal to 0.750 watts. 3 significant digits. Another very quick example, we have a bunch of 10k ohm resistors, and we want to have a resistance of 22 kiloohms in our circuit. So let's figure out how we would do that from this available bunch of 10k ohm resistors. Well, after a little bit of thinking, it should be pretty obvious that we want a 10k ohm here in series with another one. This will give us 20 k ohms, since they're in series, and then we need an extra 2 kiloohms, so we'll want to have another circuit, a part to this circuit that has 2 kiloohms. Well, it turns out if we put 5, and I won't label, these are all 10k resistors, so if we put 5 of them in parallel, the equivalent resistance of those 5 will be 2 kiloohms, and these two in series will give us 22 kilo ohms. So this is our answer, and just to prove this, remember the equation for equivalent resistance. So R equivalent for 5 resistors in parallel, we would just have 1 over R plus 1 over R. We do that 5 times, and this is equal to 1 over 5 over R, which is equal to R over 5. So when we have identical resistors in parallel, say we have 5 of them here, the actual final resistance, equivalent resistance, is R over 5. If we had 7 of them, it would be R over 7, etc. So that's a nice, easy way to remember it. For example, if you wanted to make half of the resistance, you could put 2 resistors in parallel like this, and R equivalent would equal R over 2, where these are both the same resistor. If they're not the same value, you have to use this formula up here with each one of the resistors being different.